Hello, welcome to Codeplay. The technology industry is going through a big transition right now. The way that we develop hardware and software is changing. This means that the chips that dominated the technology industry in the past, called CPUs, are now being replaced by new processors such as GPUs or new specialist AI processors. My name is Andrew Richards. I founded Codeplay here in Edinburgh in Scotland 18 years ago to help the whole industry to make this transition to new processors. Today, we are recognized as the world leader in our field. Codeplay has been collaborating across the industry to define industry standards that let AI chip companies and AI software companies work together to deliver world-beating innovations. We've been working with, for example, Renesas to enable their AI processors to work in a car, accelerating the latest AI automotive software techniques. And we've been working with Intel and their One API initiative in order to support development of hugely powerful new supercomputers. We provide our customers with a mixture of in-house software technology, specialist software development services, and open source software development. We work with your engineering teams to bring a complete AI product to the market. Codeplay provides solid, real, reliable, standards-based solutions that result in big design wins for our customers, whether it's huge supercomputers, self-driving cars, or some new AI innovations.
Advanced Driver Assistance Systems, or ADAS, are already with us today, making cars safer, but these systems have huge forecasts in the coming years, allowing cars to make safe decisions and save lives. This will happen in phases, with increasing levels of awareness and control, eventually allowing the car to be autonomous. The market projections are huge, with Strategy Analytics forecasting over 20% of new cars by 2025 providing Level 2 autonomy, where the car takes control of two or more functions for tasks such as lane change and self-parking. Level 4 can provide full autonomy in controlled areas, which is expected from 2025 and reaching 70% of new cars by 2050. There's a long road ahead, but it shows a strong interest and intent to bring the latest AI developments into automotive. Car companies have evolved from electrical systems to electronic systems, and now to software-defined systems, with the software value forecast to grow at almost 17% per year. ADAS brings together a large number of cameras, LiDAR, radar and ultrasonic sensors, combined with downloaded maps with known road data, other inputs such as driver alertness and how the objects could move, such as humans, animals or other vehicles. Extracted data from all these sources, fuse it together and make safe, reliable decision. This creates a massive compute system, and for that you need lots of software. From an estimated 100 million lines of code in cars today, the software challenge is estimated to reach 1 billion lines of code by the time a fully autonomous car is available. Codeplay has been enabling computer vision and AI systems in consumer domain for many years, and it became clear that our software solutions were highly relevant for ADAS and the autonomous vehicle. The availability of new processors, accelerators and AI programming techniques are allowing Codeplay to bring this AI world into ADAS. We strongly believe that SYCL and OpenCL open standard software are a must to enable the latest AI developers. There is nothing missing today to allow OEMs, Tier 1s, research, advanced developments and software partners to start evaluating and developing with SYCL. The ecosystem is well established and many organizations are already contributing the results, open source projects, guidance, providing the support for anyone else to get up and running. The question is more about timing than the likelihood of its adoption. When will ADAS software developers transition to a modern C++ programming style? Many companies are already demanding OpenCL or SYCL within their requirements, and it's reassuring to see real ambition and confidence in industry standards to create the 1 billion lines of code.
At At Codeplay, our aim is to enable OEMs and Tier 1s to bring next-generation AI technology to the heterogeneous platforms, providing rapid development and maximum performance as well as safety. Codeplay is already working with major suppliers of ADAS systems, supporting developers during evaluation and development with OpenCL and SYCL open standards. One example of the ongoing support is our strong relationship with Renesas Electronics. We have demonstrated that we can achieve high performance of OpenCL, SYCL, and the supporting libraries used in AI on their R-Car SoCs. This implementation can be used today to evaluate the performance and show the advantages of using modern C++ and open standard programming models in the development of tomorrow's ADAS functions. It enables rapid benchmarking of real-world AI code and testing of the latest algorithms on real hardware. We are now addressing safety requirements, as well as identifying the requirements of the OS and driver levels. The final safety product will be developed in close partnership with the end car manufacturers and Tier 1 suppliers, since each company has individual safety considerations that will permeate the stack, and therefore a strong cooperation between the different layers is required. Codeplay has years of experience of working closely on a technical level with our customers to develop solid products, which will stand us in very good stead to achieve this goal.
At Codeplay, we believe SYCL and continuous development is the best approach to achieving C++ in the next generation of ADAS systems. We have folded the ISO 262 functional safety standard into the development of our SYCL product called Compute CPP through continuous development. Continuous development is in Codeplay's DNA. All of our projects use Git, which is an industry-wide state-of-the-art solution used by all modern C++ developers. We fully understand what it takes to provide continuous development methodologies and the benefits it brings to us. At the other end of our development pipeline is an extensive test harness, automated by Jenkins, again another industry-recognized verification platform. It ensures all the products we release to our customers meet all the requirements. Our experience in continuous development methodologies makes us very well placed to develop the complex ADAS solutions of tomorrow, to enable us to deliver the necessary and frequent over-the-air updates necessary for the automotive industry that is already part of our lives today in mobile devices and PCs. At Codeplay, we are working with the existing and emerging safety standard bodies to drive forward the necessary changes and adoption to enable ADAS solutions for tomorrow. Through continuous development, we will evolve the SYCL standards, the C++ standards, the code quality standards, and our SYCL implementation Compute CPP to enable ASIL-B solutions and beyond. ISO 262 strives to guide all of us to develop solutions that are safe and free from systematic errors. With that, Codeplay have identified key components and layers required for bringing AI to automotive. And using ISO 262's decomposition guidelines, we have broken down the complexity of the stack into manageable parts, each having its own continuous development process. As part of our commitment to produce safe products and promote open standards, we have started publishing a series of technical articles called SYCL for Safety Practitioners. The first is available today, with more being made available over the next few months. This will cover many of the safety topics related to developing a computing stack. I invite you to our website and take a look.
Hi, my name is Michael Wong, a Codeplay Distinguished Engineer, and today I would like to talk about the coding, safety, and AI standards that Codeplay is driving for automotive, AI, and computer vision. Standards enable open contribution and collaboration by all entities, as well as interoperability and industry-wide verification. We have been driving the safety of coding standards in MISRA C++, updating the next MISRA, and augmenting it in future with concurrency, parallel, and heterogeneous rules. We're involved in autonomous vehicle and ML standards regarding safety. We chair the Object Tracking Task Group in Underwriter Lab's 4600 standard for safety of the evaluation of autonomous products. We're members of UK's Safety Critical Systems Club on multi and many core safety, as well as safety of autonomous systems working group. We're members of ISO IEC's TC22's road vehicles on safety of the intended functionality, or SOTIF, designed for autonomous vehicles, cybersecurity, and software delivery, which was mandated by the United Nations Economic Commission for Europe's Rule Form for Harmonization of Vehicle Regulations, or WP29. We're also a member of ISO IEC JTC1's Advisory Group 6, reporting on autonomous and data-rich vehicles. We contribute to SC42 AI and ML machine learning standards on ML trustworthiness. We will continue to drive these and future upcoming standards in coding, safety, AI, and ML, and this will enable us to have our products follow the latest guidelines.